1, 2, 3, 4.
News,
culture, astronomy,
physics,
humanities,
space,
science, travel,
Boom! Knowledge! Boom! Knowledge!
History.
humor,
technology,
Games.
business.
Good morning, afternoon, or evening, whatever time it is, wherever you are, and welcome to Boom Knowledge, a podcast with purpose. Educate, entertain, possibly inspire, certainly remind us all that the wonders of the world outweigh the woes. Also, let's level up our trivia kung fu. Knowledge Karate Chop! I'm your host, Mike Vass, and I am so grateful to share this time with you. Thanks for listening and welcome to the show. I'm coming to you from the road today in Sacramento, California, visiting friends, attending a birthday party, going to be rocking some songs on a stage and catching up with people I love, and, well, it's going to be a great time. And it's also an opportunity to test out my mobile recording rig, Podcast Road Warrior Mode Engage. So it may sound a little bit different or exactly the same. I don't really know. You don't know. We're on an iterative journey together, one that has me trying to produce the best show I can from both a sound and content perspective, striving for excellence in all things, because that is the right thing to do. So I've been thinking a lot these last few weeks about my place in the solar system. No, really, I mean my very specific place in the solar system right now, related to the sun. I've probably overmentioned the fact that I deal with some seasonal affective disorder, otherwise known as seasonal depression, winter blues, or the super corny acronym SAD. And of course, all that is related to my relative position to the awesome fusion reactor in the sky. And how does that really work? While I've talked about the seasonal affective before, I have not discussed our passage through space around the sun. I'm going to dig into that today. And actually, we'll make that segment a bit more exciting by engaging in a thought experiment. What if the Earth was ejected from our solar system entirely? Yes! And thinking about the winter and resolutions and my wildly varying energy levels also had me thinking about exercise. Specifically, when I pull myself away from level 8 of the latest Doom, which, by the by, is so good. Hats off to id Software and Bethesda for giving me countless rooms full of demons to blow off some winter steam on. So when I'm done with my heroic actions in virtual Hades there, and ready to hit the gym and say goodbye to any excess pounds, where do the pounds actually go? Where does that stuff end up, and how? I know the answer now, and so will you, and it may not be where you think. Okay, let's get this lazy winter introduction up off the couch, away from binge flicks, and out into the gradually brightening days ahead. Time to step up and get show shape. Trim the hips, cultivate the muscular regions, and get ready to sell a few tickets to the gun show. It happens consistently the same way every single year. Our magnificent little world makes a 940 million kilometer or 548 million mile trip around the sun. It sounds pretty hokey to say it, but you and I, your dog, your mother-in-law, and every other single person you've ever known or ever will know, or who's ever lived in the history of human existence, is a stellar voyager on the spaceship Earth. Our planet is a giant traveling bioorganism, with bioorganisms crawling all over it in hot bioorganism on traveling bioorganism action. It's awesome. We're zooming around the sun, which is zooming around the Milky Way, which is zooming around the local group, and so on. A grand adventure on an epic scale. But more locally, the transit around our parent star has an enormous effect on both the planet as a whole and its inhabitants, be they animals or vegetables. Let's quickly summarize the basic mechanics here. The Earth is spinning on its axis, tilted a lovely 23.5 degrees. We don't know for absolute certainty why the Earth is tilted as opposed to spinning just straight up and down, but our best guess is that early in the solar system's formation, when objects were banging their heads and cruising in a chaotic stellar mosh and pogo pit, the Earth got an unsuspecting wallop from something big, another planetary type object. Hey buddy, watch where you're going. It was such an impressive clock clean that we got a permatilt as a result. And hey, scientists also believe that's how the moon was formed. A big hit, the ejection of material, and then the coalescing of matter thanks to gravity. Voila, moon. If you're gonna get sucker punched, you might as well make a little friend out of the deal. So here we are, all tilty cattywampus, cruising around the sun in an elliptical orbit. Now, that does not mean we are revolving around Monsieur Soleil in a perfect circle. Rather, it's an ellipses, where we are closer to the big guy during one portion of a year than the other. The Earth is at its nearest point to the sun on January 3rd. This is known as the perihelion. We are furthest away on July 4th. This is known as aphelion. If you've listened to this show, I don't know, maybe twice before, you wouldn't need many more times than that. Well, you will know exactly where these words derive from, because the answer is always the same. The Greeks. We love those guys and gals. Perihelion comes from peri, meaning around or surrounding, and helios, meaning sun. Aphelion derives from away, off, or apart, again from the sun. Perihelion in January, closest. Aphelion in July, furthest away. Now, some of you may be saying, hold the phone, Vass. January is winter and July is decidedly summer, and I know what those two feel like. So how can we be closer to the sun in winter than we are in summer? Haha! I have the answer. Remember that we are tilted, my friends, on account of the Earth getting smacked upside the noggin. You see, the northern hemisphere is still pointing away from the sun, even though the Earth itself is closer. And the southern hemisphere actually gets their summer in our winter, because they are pointed more directly at the sun. Seasons have nothing to do with how close the Earth is or isn't to the sun. It's all about that tilt. I mentioned a few episodes back about being in New Zealand over Christmas one year, and I won't recap all that I said then, except to say it was warm, wonderful, and weird. Now, a next logical question might be, are summers in the southern hemisphere warmer than those in the northern hemisphere as a function of the Earth's physical closeness to the sun? The answer is, against all intuition, no. And the reason for this is because it takes more energy to heat water than it does land, and also water takes longer to cool, and there is far more land in the northern hemisphere than the southern. Wild, right? Okay, let's have a little fun with a thought experiment. What would happen if the Earth were ejected from our solar system entirely? Or if the sun just suddenly popped out of existence? Let me first set your mind at ease by saying that, as far as we know, this is impossible in the extreme. The type of apocalyptic event that could cause that level of chaos in our solar system would already be ruining our day with extreme prejudice. And anyway, we can't conceive of any such event now or ever. But hey, this is the realm of imagination. So I will wave my +10 wand of podcast power and poof, no more sun. What happens next? Well, for starters, we wouldn't notice it all for a full 9 minutes, because that's how long it takes for the light of the sun to reach us. After that, though, things start to go downhill quick. It'll get dark, real dark. And if the moon were out, well, it would go dark too, because there's no sunlight to reflect and announce its presence in the sky. Photosynthesis would cease, meaning all plants would die off, and it would get cold. Very, very, very cold. -0 degrees Fahrenheit on average within days. But colder still as time went on, charging towards an eventual surface temperature of -400. The oceans would start to freeze, retaining temperature and life for a time, especially deep in the depths, but not forever. Plate tectonics can keep that dream alive with heat coming deep within the Earth's core, but the life likely to linger longest is bacterial, and fat lot of good that does for us humans. the atmosphere would liquefy and freeze out ultimately, disappearing. Aside from the obvious breathing troubles, there would be no protection from cosmic rays and pesky radiation. To put it in the most scientific terms imaginable, we'd be boned. On the plus side, we would be given rogue planet status. These are very real, by the way. There are rogue planets floating around throughout the galaxy and the cosmos, either ejected from their home star or they never had one to begin with. And that would be us. Little rogue Earth, too cool for school, by about minus 400 degrees Fahrenheit. I have a long history with weight loss and gain in my life. And actually, I think most of us do, with varying ranges dependent on who you are, your habits, your metabolism, your age, and so forth. But hey, speaking for myself, I do my best to keep up with the exercise and actually have been pretty consistent the last decade or so. Still, when winter hits, I pack on a few extra pounds. Holiday feasts, a desire to hibernate, and a decrease in overall motivation are to blame. As the days get longer and my motivation grows, however, I suck it on up and attend to the pounds once more. Now, as to where all that food went as I was gaining the weight, that's easily observed. My waist and my face, mostly. I can see it every time I look in the mirror or at a photograph. For the record, I wish it went to my tiny butt, which could use a lot more of that action. But anyway, the evidence is there. Where does it all go when I lose it, though? To answer these questions, we first need to talk about what fat is. The main components of body fat are something called triglycerides. Chemically, triglycerides are composed of carbon, hydrogen, and oxygen atoms in various configurations. And the main division between triglycerides is saturated or unsaturated. If you've ever wondered what saturated fats are saturated with, the answer is hydrogen, which bonds to every carbon atom in every way it can. Saturated triglycerides are more likely to be solid at room temperature and have a higher melting point as well, which makes them really tough to get rid of. But get rid of them we do through exercise. Now, it's a common misconception that burned fat turns into energy, but converting matter into energy is actually really, really hard. Fun fact, if you could convert fat in your body directly to energy, you would explode, because physics is glorious like that. Thankfully, this is not what happens. So an obvious conclusion might be that we poop it all out, right? Wrong. Our feces is, and again, I never thought I would talk about poop nearly as much as I do on this podcast, but we just keep coming back here. Sorry, Mom. I swear I really am a successful grown man, honest. Your poop is metabolic waste. It's made up of nitrogen compounds, water phosphates, sulfates, and so forth. Stuff the body isn't going to be using. A small amount of cholesterol may be present, which is a form of fatty acid, but not much. And in fact, without going from biology lesson to full gross out, if you did have too much fat in the stool, it could be a real problem. It would mean that the fat intake process isn't working right. And it's also really icky. You don't want to know what this looks like. Any weight loss from that process would come at the price of nutrient absorption being broken, and that's bad. Time to see a doctor bad. Okay, how about peeing it out? Well, actually, now we are on to something. Remember that I said triglyceride or fat is composed of 3 atoms, carbon, hydrogen, and oxygen. About 16% of what's left when you burn triglyceride is in fact hydrogen and oxygen in the form of H2O. Good old water. So yeah, you actually pee out some of it, 16%. Good job, you. But what about the rest? Well, the answer is fascinating. What's left over from that chemical process making up the remaining 84% is carbon dioxide. If you were to lose 100 pounds in the course of the next year, 14 of those you would pee out, and the rest you would exhale. How cool is that? Now, I know you may be thinking at this point, and I'm sorry to tell you that the answer is no, you cannot breathe harder to lose weight. The body doesn't work that way, which is a jib. Time once more for the frag list. This first one actually comes from Jason in Bend, who reached out to me after episode 22 to say, "Hey Mike, were you talking about a different Jason? Because I didn't send you that thing about heavy metal sharks." To which I said, "Oops, I wonder who did." Well, if that was you, please shoot me a message on Facebook or send an email so I can apply proper credit where credit is due. These things are really important to me. Anyway, Jason really and truly did send me a link to andvinyl.com. That's ANDVINYLY.com, which is a company and service that will press your ashes into vinyl. For about €3,000, you can send these guys any audio you like. Words from Beyond the Grave, your favorite Beyonce or Iron Maiden or Julio Iglesias or Weird Al Yankovic tune, and they will press a record that includes that audio and your post-cremation form. No further commentary required. And congrats, Jason, for accidentally making it into 2 episodes in a row. Love you, buddy. Next up, from listener Rain, who sent me a very nice note about episode 22. In addition to this submission, a new study published in the journal eLife is suggesting that being left or right-handed actually derives from gene activity in the spinal cord. A group of researchers led by biophysicist from Ruhr University, Bo Chum, monitored gene expression in the developing spinal cords of babies between the 8 and 12-week milestones. They discovered asymmetrical activity there, specifically in an area which delivers electrical impulses to hands, arms, legs, and feet. And the activity they found occurs ahead of development of the connection to the motor cortex in the brain, which means the brain isn't the culprit for determining handedness. The spine is. Researchers also believe that environmental factors as the baby grows within the womb help to determine the outcome. That's a big discovery. Thanks again, Rain, for pointing me that direction. I appreciate it. And I have just 2 more delicious little trivia bits before we close on out here. In episode 18, I talked about the largest objects in the universe. And when talking about stars, I mentioned Betelgeuse. What I didn't mention is that this big star is on the verge of a supernova, which could happen anytime, a couple thousand years from now or tomorrow. The big guy is ready to pop. When that happens, it is believed our sky here on Earth will be lit continuously for about 2 full months. Wow. And finally, the blood cells in your body take 60 seconds to make a full circuit. In a circulatory world, one man shrunk to microscopic scale, thanks to science, must traverse the body of a friend to save him from, something bad. Nicolas Cage is Blood in 60 Seconds. Thanks for listening, friends. So concludes yet another needlessly dramatic yet nonetheless informative episode of Boom Knowledge. If you have a sweet submission for me or you just want to say hello, well, I have multiple ways for you to do that. Check out my Facebook page or my Twitter feed or shoot me an email at mike@boomknow.com. That's BOOMKNOW, or just mike@boomknow. I thought about any way you could do that. I'm about as responsive as they come, and I love the human connection a relatively isolated show does not afford me otherwise. I also have an Instagram page where you can see images of folks I interview, and over time, I'm sure all kinds of other weird stuff as well. Have an amazing weekend. Stay warm, stay cool, keep breathing out that CO2, fat-laden or otherwise, and I will see you next week in the future.
Boom Knowledge.